Hello MIS 411 class, welcome to Chapter 4, Video 4, Transforming EER Diagrams into Relations, Part 2. So in Step 2 we mapped weak entities. Now in Step 3 we're going to map binary relationships. Now hopefully, as you recall, a binary relationship just means there's a relationship between two entities, right? Binary two, and there's a relationship between both entities. You may remember as well, or not remember so much as be aware, the relationships can have different types of cardinality, right? And when we're talking about cardinality right now, I mean from one side to the other. So you have one-to-many cardinality, you have one-to-one, and you have many-to-many, right? And so the process of mapping those binary relationships, those three types of binary relationships, will differ slightly for each of those classifications, right? So what we're going to start with is one-to-many. It's the most common, and it's, I think, probably the simplest, right? So as we're used to by now, the first step is going to be to take the entities you have in your diagram, and you're going to create relations, one relation for each of the entities. So here we have the instructor and class entities. An instructor teaches 0 or more classes, and a class is taught by one and only one instructor, right? So we have a one-to-many as we're trying to model. So we create two new relations, an instructor relation and a class relation. They match the names of the entities they're derived from. The identifiers for each of the entities come down and become the primary keys, ID in both. The normal attributes, as usual, name and job title come down and become fields, name and job title. Subject and number become subject and number. Down below, showing the alternate representation. And that's all you need to do for Step 1. So for Step 2, what's going to happen is we're going to add a foreign key reference to the parent from the child. And hopefully you remember from the section on foreign keys, for a one-to-many, you're going to have a parent and child relationship. And the parent can spawn many children. The child can have one parent. And the child's going to be designated. You're going to be able to quickly identify them visually by the fact that the child has the crow's foot. And the parent's going to have the 1. So as it says, we're going to place the foreign key reference to the parent in the child, right? So the child in this case we can identify as the class. So we place the foreign key in the class relation, referencing the instructor, right? And so down below you can see it as well. The instructor ID foreign key is now placed in the class relation and references the instructor ID. So this is a pretty simple process. The one-to-one binary relationship is actually not that dissimilar from one-to-many. As before, we're going to first create the relations. I'm not going to go over them again. And just to clarify kind of what we're looking at, we have a one-to-one. We have instructor. What we're saying is that an instructor must be assigned one and only one office, and each office may be assigned to at most one instructor. So the interesting part happens when we get to Step 2. And in Step 2, if both are optional, right, or both are mandatory, that is to say, if both are optional 1, like 0, 1, 0, 1, or both are mandatory 1, 1, 1, 1, 1, then it doesn't really matter which one you place the foreign key in, as long as it references the other. However, if one is optional and the other is mandatory, you place the foreign key in the relation on the optional side, referencing the relation on the mandatory side. So here, which one's the optional side? The instructor is. Right, and the mandatory side is the office. We can see by the cardinality right here. So we're going to place the foreign key on the optional side. Here we go, office ID, referencing the mandatory side. We have office ID foreign key in the instructor relation, referencing the ID field, the ID primary key in the office relation. And again below in this notation. So in both the one-to-one and the one-to-many, all you're really doing is adding a foreign key reference on one side to the other. You don't have to create any extra entities, any extra relations, or any fields other than the one foreign key field. Finally, we come to the many-to-many relationship. And actually, for the sake of simplicity, what we're going to do here is actually we're going to convert it to an associative entity. You should all be familiar with this process by now. When we have a many-to-many, whether you go by converting it to an associative entity first or go by kind of the books model, you're really going to be creating this intermediate entity either way. So I don't think it saves you really anything to, and I think it may be confusing to see them as two different tracks. So what I'm going to say is convert it to an associative entity first, right? Even if it has no attributes, just convert it to an associative entity and then skip to step 4, which is where we will actually convert associative entities to relations. So mapping binary relationships to a relational model isn't particularly difficult. It generally consists of adding a foreign key reference in one table to another table. And that's of course based on the type of relationship you had between the entities in your conceptual diagram. So here we have an instructor can teach 0 or more classes, and a class must be taught by one and only one instructor. An instructor must be assigned one and only one office, and an office may be assigned to at most one instructor. And we of course have the foreign keys. So the class has a foreign key, instructor ID, referencing the ID of the instructor table, and the instructor has a foreign key, office ID, referencing the ID of the office table. So in practice, what could this give us? Let's say that we wanted to know what was the office number, the room number of the instructor teaching all the CS courses, so we can deliver them a piece of mail, for instance, telling them about a new scholarship available to CS students, right? So we would go to the class table first and say maybe subject equals CS, and we would get these 3 rows, right? And then we go over to the foreign key and we say, well, who's teaching CS courses? And we get instructor ID 1, 1, and 1. Now it doesn't have to be 1, 1, and 1 actually. In this example it is, but it could be 1, 1, 2, for instance, right? But we take those instructor IDs, or in this case that one instructor ID, we go over to the instructor table and we say who has instructor ID 1. We find that it's James Connors, right? But we still want to know what room number James is in. So we go over to the foreign key office ID. We find that in fact is actually office ID number 1. So then we go over to the office table and we say, well, what building and room is office ID 1? And we find that it's in Markstein 101. So in that way we would use foreign key references essentially to get from one table to another, essentially merging the data together. So the concept of using foreign keys to get data from one table based on the information in another table is going to form the basis of anything beyond the most trivial SQL statements. You will almost always be joining at least 2 or more tables. Many of the examples we've been doing in class really have you selecting from a single table, but in practice, it's almost never the case that all of the data you will need, you'll be able to get from a single table. So understanding this concept of foreign keys and how tables are linked together is really crucial to being able to do anything more than the simplest of data retrieval. In step 3, we mapped binary relationships, including a many-to-many relationship, or we didn't really map that, but I said convert that to an associative entity and we'll deal with it in step 4. And the reason I said that is fundamentally an associative relationship is the natural culmination of a many-to-many relationship in any way. And I think you'll be happy to know that at this point, all the mappings that we're going to be doing really are kind of just based on, or derivative of the first couple mappings we did with the regular entities and the weak entity and the binary relationship. So as before, well, let's see what we're starting with. We're starting with an associative entity between student and class. This could have started actually as a many-to-many relationship, right? A student enrolls in 0 or more classes, and the class is comprised of 1 or more students. And then we convert it to an associative entity. A student now engages in 0 or more enrollments, and each class must be in 1 or more of these enrollment records. So as before, the first thing we're going to do is convert all of our entities into relations. And I think at this point it's probably become familiar enough that I don't need to go over how that all works. In step 2, what we're going to do is we're going to add 2 foreign keys, one for each of the original non-associative entities to the associative entity, right? So originally we had enrollment as the associative entity with the grade attribute, which became the grade field, and now we've added foreign keys, one for student ID, referencing the ID primary key in the student relation, and one for class ID, referencing the primary key ID in the class relation. As always, we keep the relationship cardinality the same, and as you can see, we didn't create any new relations in order to affect this addition. In step 3, kind of similar to the weak entity, what we can do is we make a choice. We can say that the primary key for the enrollment relation can either be the natural key, which is going to be the composite primary key composed of the student ID and class ID foreign keys, or if we wanted to, we could actually create a surrogate key. I'm not going to go over that process again, but just essentially what it is I would create a new field that may be just called ID, and I would actually assign numbers to each record in the enrollment table. And if I did so, then the student ID and class ID would still be foreign keys, but they would no longer be part of the primary key. Again, the whole point of the primary key is to uniquely identify one record in this table. So it's a design decision whether I want to do that with a natural key, using existing fields, that a combination of which can uniquely identify a record, or if I want to come up with my own brand new field, which is essentially just an auto-incrementing number. In step 4, we mapped associative entities. In step 5, we'll be mapping unary relationships. As you may recall, a unary relationship is where you have an entity which has a relationship with itself, and oftentimes that can be sort of a hierarchical relationship, like as you can see on the screen, where you have maybe a one-to-many. You have an instructor is the department chair of other instructors, right? Well, so every instructor has exactly one, mandatory one department chair, and every instructor can be the department chair for 0 or more instructors, because obviously many instructors are not department chairs. And a department chair, for those who don't know, is just the head of the department, like the head of the CS department, for instance. So this actually applies to both one-to-many and one-to-one relationships. So a one-to-many would be like the one we just discussed, being a department chair. One-to-one might be at any point in time, an individual is allowed to be married to one and only one other person, optional one, right? So it would be, and is only allowed to be married to by one and only one person, right? So it would be a one-to-one relationship. And so the following steps apply to both one-to-many and one-to-one unary relationships. So the first thing you're going to do, as you're probably used to by now, is you follow the steps for mapping a regular entity. At this point in time, I'm not going to go over the details of that. And then in step 2, what you're going to do is you're going to add a foreign key reference in that in the new relation, referencing its own primary key. And this is also called a recursive foreign key, and it's called recursive because it goes back to itself. It's actually very simple, as you can see. All we did was we added this foreign key instructor ID to the instructor relation table, pointing back to the primary key ID. And that's all you have to do for a unary relationship on a one-to-many or a one-to-one. Now, with a unary relationship many-to-many, right, and here we have an example of a class, can be a prerequisite for 0 or more classes, right? You might have a foundational class, CS 100 might be a prerequisite for every other CS course, right? And classes can have 0 or more prerequisites. You might have CS 500, which requires both CS 100 as well as CS 200 and CS 300, etc., right? And so here we have a many-to-many relationship. You may or may not recall in the video I did on associative or on unary relationships and associative entities, is what you can do in this is actually kind of unfold it and treat it almost like, or treat it basically the same as any other many-to-many relationship. And so what we're going to do is first convert this to an associative entity relationship, like so, right? So now we're maintaining the same logic. A class requires 0 more prerequisites, and a class is required by, 0 more other classes, right? So reading out this relationship, if you were to unfold class and make sort of a shadow copy on the other side of prerequisite, you would see that it's basically just an associative entity relationship, with class having the one, the mandatory one over here, and then the other phantom class on this other side also having the mandatory one, right? So at that point, you're going to basically just do what you do for an associative entity. So we follow the steps for mapping regular entities. We take class, prerequisite, we bring them down. Prerequisite itself doesn't have its own identifier just yet, as you may recall from associative entities. And what we're going to do there is then we're going to add the foreign key relationships. So in the section on associative entities, we had a foreign key relationship to each of the other entities, right? Prerequisite, basically in this model being between two class entities actually has 2 foreign key references to the same relation, the same table. The one difference is, maybe just to think about, is because we're talking about the same table, right, we needed to name these foreign key fields a little bit differently. That is to say, we can't call them both class ID, right, because you can't have the same field two fields of the same name in the same relation table, right? And remember, what you name this field is entirely up to you. I've been naming them, class ID to reference the class's ID, and instructor ID to reference the instructor table's ID. But you could actually name this whatever you want. You know what I mean? You could name this, course number or something. Now you probably wouldn't want to do that because it makes it much more difficult to recognize what its intent is. But really, the naming of these is up to you. So in this case, I chose prereq class ID and class ID. And so the ID here is that one of the foreign key referencing the class table that has the prereq class ID would be the ID for the class that is acting as the prerequisite. And then the class ID would be the ID of the class that requires the prerequisite. And again, this is kind of arbitrary. This is just how I would name them, but you can name them however you would like in this situation. Down below, you can see, again, for the most part, this is just what we've dealt with associative entity mapping. The only difference is because you're dealing with the same relation twice, things get, visually at least, a little bit different. As well as, like I said, the naming convention for the fields. So here we see the prereq class ID and the class ID in the prerequisite relation table. Both reference the ID primary key in the class table. And that's all there is to unary relationships. So in the previous step, in step 5, we dealt with mapping unary relationships, relationships of an entity to itself. Now we're going to go to ternary relationships, which is a three-way relationship. And this actually holds true for not only ternary, but anything above 3. So n-ary, 4-way relationships, etc. And just as a quick recap, obviously in step 3, we dealt with binary relationships, relationships between two entities. And the reason we dealt with that so early on is really because binary relationships are the ones you'll encounter the most and kind of form the basis for many of the other types of mapping processes that we go through. So with ternary relationships, what you're really going to be dealing with is essentially kind of like the associative relationships or mapping that we dealt with in step 4. And so what you can see on your screen is kind of a ternary relationship. I'm already converted to an associative entity, so I'm going to kind of skip that step. I mean, it's pretty straightforward, and I've dealt with it in previous videos. So I have student, class, term. There's an enrollment that combines all three of those things. An enrollment takes place, enrollment record would incorporate a specific class like CS 101, a specific student like John Johnson, and a specific term like fall 2022. So, as is our custom, the first thing we're going to do is take the entities on the table and convert them into relations, right? So we've taken the term, student, enrollment, class entities, and now we have term, student, enrollment, and class relations. As usual, we're bringing the IDs down, or the identifiers down as primary keys, and as usual for an associative entity relationship at least, you see that enrollment doesn't have a primary key defined just yet. In the next phase, and again, this is just kind of like the associative entity mapping that we did in step 4, we're taking a foreign key to each of the original entities and we're placing them into the associative relation. So as you can see down here, we have foreign keys to student ID, class ID, term, and over here we do the same. And then finally we make a decision, and again, this is no different than what we've done previously. We can either, if we choose to do so, we can use a natural key, which is essentially a composite primary key composed of the various foreign keys, right? So all of these foreign keys would be part of that natural key. And if necessary, because sometimes you actually, that in and of itself is not sufficient to be to uniquely identify an enrollment record. If necessary, you might have other attributes as well, but if not necessary, you don't need them. Alternately, and as this gets more and more complicated, this becomes, kind of a really large primary key. So the other option, again, is to use a surrogate key, right? So of course we would still have the foreign keys into the various relations. However, they wouldn't be part of the primary key, and the primary key is something that we would generate, we would create ourselves and just kind of auto number it, right? So we would have enrollment 1, 2, 3, 4, 5, and each record in the enrollment would combine foreign keys for the other relations. So ternary relationships are not, mapping ternary relationships are not that dissimilar from all of the things we've done before. And even though it seems like there's a lot going on in all these different steps, really there's only a couple fundamental principles which we'll get to pretty shortly.